Hi, folks. Anyone there? Can you hear me?
Hi.
Hi, Zori. Hi, Andrew.
Hi.
Hi, Zuri.
Hello.
You guys get your ballots? You ready to vote? No. Okay. We're gonna spend a few minutes here to let people come in. How's everyone holding up in the storm?
My house has 2 leaks, so that's going great.
That's wonderful. That's free water, right?
Yeah.
My Wi-Fi is acting up.
Yeah. I think one of the things about being on Zoom is harder. So we've done this before. When I first taught computational, we were fully online because of the panorama. And I think it's possible. I think it's a lot better for me to be in person and be able to just look over your shoulder and be like, oh, that line right there. But if we don't get as far as we normally would today, that's okay. This is why we build in Slack into the schedule. So we'll give it a try unless everyone here is completely convinced that they want a day off. So if you do feel that way, feel free to drop that into the chat privately to me, and then I can just sort of take the temperature of the room. I'll assume no one is on campus and they didn't accidentally go to campus. Cool. Gonzalo almost drove to campus. Good. All right. Well, I'm glad you did not. Yeah, I wish they would, sort of emails get lost, right? And so if you hadn't happened to notice that exact email, I feel like that could have been horrifying. We'll wait a couple more minutes because I know online it's a little tricky. If folks are trying to, if they're trying to find the room or anything else from Canvas. Who is presenting today? Do we know?
I am.
Sorry.
Yes.
Are you ready to present?
Yes, I am actually.
Okay. And that's good. That's always important. So we can do that presentation and we'll jump into some examples and whatnot. Zori, would you prefer for me to share my screen and then you can like scroll through it, or do you want to share your own screen?
You can share your screen. That'd be good.
Okay. So just let's get set up while people are still coming in. Where do you want to start? What page of the PDF?
I think it's 75.
75 user-defined functions?
Mm-hmm.
Okay.
Yes.
Okay, so we'll start in about 2 minutes, but let me just throw it up here so everyone can see it. Anyone have any questions or issues that they want me to be aware of? Oops. How's that for everyone's screen?
Good.
Good.
Looks good.
Okay. And for folks who were doing the pair programming and maybe didn't get as far as they wanted to, were you able to come back to it and add either comments or make any progress? Okay. So there's another issue with being in Zoom and then no one has their screens on and I can't see anyone nodding. So feel free to use the reaction button so that I can see you and understand where you are like intellectually. So it's going to be really easy to lose you. It's going to be really easy for you to sort of zone out and, keep cooking your quesadilla or whatever lunch you're having. I would strongly recommend that, you have your computer open and you're doing the code. After Zori goes through user-defined functions, her section for today, we're going to jump into breakout rooms. And in the breakout rooms, I would suggest that one of you has CoCalc open and the other person, you can have your book open or you can have anything else and just screen share. And then whoever's driving screen shares, and then they can type in and you can work on the algorithms together. And then I would recommend, of course, switching between problems if that's okay. Okay. Zori, take it away.
Okay, so for user-defined functions, there's a lot of different parts to this, but I kind of want to start off with saying that the whole summary for user-defined functions is pretty much you're defining your own code that is reusable. So you can pretty much make loops in it, you can make sets, lists, etc. And then kind of redefine them as you go. So I have notes here, so if you hear pages flipping through, that's me. But so you can kind of scroll down, please. So for the first example, it's showing us how we can define such cases. So for this case, they're doing factorial. Oh my God, I cannot talk. Factorial of integers.
It's a Monday.
Yeah. Factorial of integers, and they're doing all the same parts that we've kind of talked about, defining them, and then how we can use a loop in order to recall certain or all integers from 1 to n. And then showing us how when the loop finishes, how that looks like. And also, instead of defining each integer, you can also define just factorials, which can give you all those products. And then within this code, you can also say something for, okay, so let's say you talk about a loop in this kind of function, and then you want to define a factorial of a certain number. So if you scroll down a little bit, you can do, you can call a factorial of 10 or a factorial of a certain product that you would like for B right there. And that can be called within the function. So a thing about user-defined functions is it only works if it's within that function. If you call a certain product, like let's say you call A and B outside of return or outside of the function, it won't work. It'll pretty much just go empty. So that's just something to keep in mind for user-defined functions.
Okay, good. So let's pause for 1 second just to walk people through what's actually going on here, right? So I'm hoping that folks are following along at home. If you have your CoCalc open, maybe you don't have multiple screens at home, I totally understand that. But let's imagine in our mind what's happening here. So before we had this loop, and it was pretty straightforward. What it was doing is it was starting off, it was initializing f at 1, and then it said for every k in the range 1 to n plus 1. So that's going to give us, let's say n is the number 10. What numbers does this give us here?
1 through 11.
1 through 11. Very good. Does it include 11?
Yes.
Okay, interestingly enough, range does not. Isn't that weird? So you're going to get 1 through 10. So the numbers that end up in here, right? So if you're doing a factorial, for example, you want to do 10 factorial. It's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2, right? And this does start at 1, starting with 1. So 1 times 1 is 1, okay? The next one is 2, 3, 4, 5, all the way up to 10 and including 10. Does that make sense?
Yeah.
Okay, good. And then it doesn't do anything with the result. But we notice that there's this different thing here, right? And so Zori is pointing out that you can make this function. And these functions work very similar to how we think of them in mathematics when you have, f of x equals something, right? And then you actually put the x in and you get something out. This is very similar, and this is how we want to think of them. And you can't tell right now, but when you go into CoCalc later on, you'll notice that there are some special words here. What is this word, Zori?
Define.
Define. Do you want to explain that to us?
Yeah. So when you're defining or it's kind of like in the beginning where it says f is equal to 1.0, or for certain integers that they want to call, or since we know we're working with factorials of integers, you can call that function essentially. So you can define what you're looking for, which is that factorial. So if we're looking from integers from 1 to n, you can define n as a factorial and then call or define underneath what you're looking for, which is that f equals 1.0, and then say that it's for the range in what you're looking for, how you want it, and then return it.
Good. And what does this return mean?
You're returning your, I guess, your factorial integer of your f.
Right. So this thing that got updated, right?
Yes.
So for folks who are following along, I know that you were very diligent about reading the textbook this weekend. So Zori, don't answer this one. This section here, so let's say we write the code. Okay, so we write this code at the beginning because we're going to use it. And then I call it down here, and maybe this is a different box, and I say a equals factorial, print a. Okay. Does this stuff here, if I said, you know, if this is in its own box and I shift enter it, does any of the stuff that's in here know about what's out here?
Can you repeat that?
Yeah. So the question is, inside of the definition, I have some letters, F, I have K, I have N, all of these things. Now, N is a little different because I feed that in. So there's this loop. Is this definition considered part of my code? Then what I mean by that is if I have F equals 1 right there, and I go and I type here, print F, will it know what this is?
F only exists within the defined function.
Ah, it only exists within the defined function. Exactly right, Alfred. So in that context, this is like its own little box that you build. And when you shift click it, when you enter it, right, it won't produce anything, right? It's waiting until you give it something like this. And then it will assign the value F to A. Do we see that? Shake your screen if you understand. Okay. All right. Thanks, Zori. All right, Zori, go ahead.
Okay. Can you scroll down a little bit, please?
Yeah. Let me know when.
That's good. So what we were talking about earlier is how the function only knows about things that you define within it. That's can also be called local variables. And pretty much it's just saying what we were just talking about, that those are only variables that are called or defined within the function. So if you call them anywhere else outside of the function, they won't work. They will go back, they can be defined as anything else. And that kind of gets messy. So it's good to know what you're specifically defining it for within that function. Another thing that it talks about is where it says user-defined functions allow us to encapsulate complex calculations inside single function definitions. So this is also giving us, can you scroll down a little bit, please?
Yep.
This is giving us an example right there, it's good, of using cylindrical coordinates. And if we're trying to find a distance between certain points or origin, it's essentially telling us, okay, so we can define x, y, d within this function, define it as what you're looking for, which is your distance and your coordinates that you're working with. Scroll down a little bit, please. So if you write those functions and you return them, that's good. If you return them, you can get your set of coordinates that you're looking for. And a little bit below that, it's going to show us another way how to write this, but how we can use it with lists or arrays or any other complex situations that we want within the function. Let's go down a little bit, please. So this isn't right here. Oh, too far. Right there, yeah, that's fine. So you can, like I said, do this with arrays, different types of assessments that you want. And that can work with setting different variables, just more complex things that you can call. Let's go down.
And just to clarify a little motivation here, if we think about something like, let's say we want to track the trajectory of a rocket, and we have these calculations that we're going to be making to its trajectory. So we want to measure the X, the Y, and the Z. It might make perfect sense to do that inside of a function, and then at every time step, return an array that has the position variables, right? And that way you can just get all of those position variables one after the other and use those to figure out how your rocket's going to fly, right? Okay, sorry, go ahead.
Okay. Scroll down a little, please. That's good. So pretty much it's just also telling us about how we can arrange these lists, arrays, or any other complex situations that we want, and how to print them pretty much. So it'll also tell us if we want to print certain products, you can also empty those original lists and alter them. So what I'm saying is, if you're working with a user-defined function, and let's say you have a certain list, A through C, and you want to empty that list, you can call it to become empty so that you can rework it. So it's pretty much interchangeable if you know what you're, I guess, looking for or what you want your end product to be.
Okay, good. Does anyone in the classroom, not Zori, who's read this already, but does anyone in the classroom have an idea of where this might have already been helpful had you known about this, say, on Wednesday?
Would it have helped for like the second part of when you were calculating the atomic levels in like part C and D, so you could have had your own separate like defined list for each variables and then plug that back into the bigger equation?
It's 50% there, right? That's the right problem to think about. So in your work, you had like running through every Z and running through every A, and then figuring out what, given a Z and an A, what the coefficient was. So you can do this in a number of different ways. And again, remember, we talk about the fact that for coding, there's not one way to do everything, that it's kind of an art form. So maybe you create two user-defined definitions, one of which is for A and N, just return that that if loop, just pop that right into a definition, put A and N, and then return whatever the name of your coefficient was, right? That could be one definition. You might also think to yourself, well, perhaps the entire process of finding the one which has the highest binding energy, I think it was binding energy per nucleon, right? Was the thing that you were calculating in step C. Maybe that entire thing can be stuck into a user-defined function, right? Okay, sorry, go ahead. Sorry.
Okay. Scroll down, please, to the next page. That's good. So here we kind of talk about more of lists and arrays and something that's called a map function. And pretty much it's just applying your old list to making a new list and how to redefine that user-defined function that we originally had. So a cool thing that they talk about, if you scroll down a little bit, to the next paragraph, I think. Oh, right there, it's good. It's pretty much something that they talk about how we can make our own definitions and import them from our library. So how we've been importing like NIMPY or how we've been reporting all those math, all that stuff that already comes from a library that CoCalc already knows of. But we can make our own, which is I thought was really neat. So if we kind of want to shortcut a certain let's say function, but we know what that definition is, you can create that and import it into your own function or your own library, sorry, and pull it from there whenever you need it, which I thought is neat.
Yeah, so we can pause there for a second, right? Because this is really giving you a look under the hood, which is this is how NumPy is created, right? We're talking about an open source software here. And what that means is that anyone can contribute packages and libraries. And so let's say you're working on, you do galaxy simulations. So what you're doing on for your graduate work or maybe for your faculty research is to simulate how galaxies form. So that's a very specific, set of tasks. And maybe you build a very specific set of definitions in Python just for you to use. But then your friend Bob comes along and says, oh, I really, I'm interested in that. So you post them to the internet. And now anyone would be able to download your file, call it whatever you want, like my definitions there.py, add it to the same folder that they're working in. And just like you would with NumPy, they could pull your functions in and they could simulate galaxies with you, right? Okay. I know you're all clapping, but alone in your own rooms. Okay, go ahead, Zori.
Okay, scroll down, please.
Thanks,
Okay.
Alf. Appreciate it.
Okay, so for the next, I think like 2 pages, they kind of just give us examples with using prime factors and prime numbers. You're defining those factors, defining what you're looking for, and this is kind of where I don't understand the append part. I know it's talking about your division operation and stuff and how to be careful with it because it actually floats things instead of using divisional operations.
Mm-hmm. Sorry, so what's the question here?
I guess how to describe this part.
Okay. So I would argue that we should probably do it. So let's have a look at today's agenda. 212. So let's just scroll down to 212 really quick. Because I think yeah. So because I'm really smart and I planned everything out way ahead of time. And then I gave Zori money to pretend like she didn't understand this so that we could do this together. So we should do this as a group. And we should code this up and we should see how it works. Because this version right here is going to lead directly into exercise 212, which is our pair programming today. Does that make sense? Yay, okay. So everyone go ahead and pull out your CoCalcs and put this in just by hand, and every single one of you doing this individually. And then we'll break up into groups after we've explained this part through. Okay? Okay. Let me know when you have your computers open to this section. You have your CoCalc. And you usually can copy and paste this in, but if you can't copy and paste it in, you can be typing it. And so when you're done, just put it in the chat that you're done. Missouri wins fastest coder award. Second place. Nice, third place. Now we're picking up steam. 1 per minute. We'll be done in like 5 minutes. Nice. Fourth place. There we go. Fifth place. Who's going to be last? No pressure. All right, Alfred, that's a way to put it in the chat. Not last though, that's good. All right, there we go. I think that's everyone, right? Okay. So now the first question to ask is, what is the fact, like this works. I assume that you typed it properly and everything is perfect and it looks exactly like the book. So let's go ahead and use it. Let's do Shift Enter to use this piece of code. And even though I can't see what'll happen, I'm gonna assume that nothing happens. So you press Shift Enter and it just simply sits there. And you think, well, I can't tell anything. So here's how we test it. Now we write the word factors, and then inside of the parentheses, we're gonna put 37. And what are the factors of 37? Ah, okay. Is 37 prime? Everyone's counting in their head. They're thinking, oh, is 37 prime? So hopefully everyone only got 37 and 1, if the 1 is even in there. Okay. And so now what about 36? Very good. All right. So now one thing that we want to try here, now that we've written this piece of code, we want to investigate just using the user-defined functions, and then we're going to let Zori finish her presentation about what we understand and what we don't understand. So we said that the stuff inside of the definition doesn't know anything about anything outside. And similarly, the stuff outside doesn't know about what's going inside of the factors definition. So let's test that hypothesis. So now we have this like definition, and in a different box below, I want you to ask the computer to print the following letters. Print K, comma, N, right? Comma, factor list. And I want to see what it gives you back. No, print it outside the function. Print it in a separate box. Thank you for clarifying. Yes, good. Okay, that's exactly what it's supposed to do. It's supposed to break because it doesn't know what those things are. Okay, so just like Zori was saying earlier, the information inside of our definition has no knowledge of the world outside and vice versa. That's good and bad, right? That means that I can use letters like I and K inside of definitions, and I don't have to be worried about them. So let's try one more test. Let's see if it goes back the other way. In a separate box, not in your definition, write that apple equals 2. And then inside of your definition in the factors list, at this part right here where it says K equals 2, create a new line and do apples times equals 2. Does that make sense? Fingers in the chat. I need to clarify what I said.
Do you mind clarifying what we were supposed to print again? Sorry.
Yeah, so let's start here. So we've built this definition, and then we have a separate piece of code. So we've run that before. We know that it works. We have our factors list. Good. And then we have a second box down below where you're just going to write the word apple equals 2. So the variable is called apple, and you're going to set the value equal to 2. And then shift enter that so that apple exists outside of the definition. And then you'll go back into the definition. You'll make a new line at this place, K equals 2. Just at the end of it, put your, I don't know what that's called, the line up and down, and then press enter so that you get a new line. And then in that new line, in the space in between K equals 2 and the space before while, I want you to put the statement apple times equals 2. Let me write it like this. Apple times equal 2. Okay. So what you're seeing here is that if this were not inside the definition, our expectation would be that apple would now be 4 because 2 times 2 is 4. And normally every time that we run this type of a times equal, it'll double, you know, or times equals 2 would double. But if you did times equal 3, whatever. Does that make sense? Okay. So now I want you to do one thing. So you have apple equals 2. And then below that, write the factor list, or sorry, factor with your parentheses and 36, just like you had before. And then I want you to, after that, write print apple and see what the value of apple you get back is. Ah, okay. So Zuri has pointed out that factor isn't defined. Are we say factor or factors?
I had it as factor.
Okay. That might work. So if you put the word apple in there, right, you're going to get an error because apple will not have been defined before. So I don't know exactly what your error looks like when we go into the groups. I can look and see if it's factor or if it's apple that's actually ruining it, but it's inside the definition factor. So maybe it says there's a variable inside the definition factor that isn't defined, which is what we're trying to do. So in fact, the computer inside of the definition has no idea of the world around it. So apple just doesn't exist. So timesing equal it won't work because it doesn't know what its original value is to times it by 2. Does that make sense?
I think the error for us says local variable reference before assignment.
Okay, bingo. That's the right one. It's the same thing that I just said, but in computer talk. So local variable will be a variable that's only found here in the definition. And then you use it, but you haven't created it. So let's let Zori finish her presentation. I know that we kind of got distracted here. She's going to walk us through the parts that we do understand. And I would greatly encourage you to write comments on what each line does, because we're going to take this code and we're going to build on it to find prime factors and prime numbers in our pair programming. Okay. All right, Zori, what's the first line do?
Defining what our factors are. So,
And what is n there?
we're just, when we write the code, we're defining that as our factor that we're working with.
Right. So in our mind, we're thinking, okay, we want to find the factors of 37. What are they? And so we'll be n equals 37, right? Okay, good. What's the second line do?
Calling a factor list or defining the factor list as something that we will put in that bracket.
Good. So remember, this is kind of like what we just showed with the apple, breaking it on purpose. So in order to be able to use something, we have to create it in this world. So factor list was initialized, and it's initialized as what kind of list?
Prime factors
What's that?
or prime factors.
Well, right now, at this point in the code, does factor list have any information?
No.
No, it's an empty list, right? So it doesn't know whether it's strings, whether it's ints. It has no information at all, actually, right? Okay, good. And then this line?
Defining a variable and setting it to 2.
Good. And what does this do?
Talking about what we're gonna do with that variable. So it's k and setting it to a factor.
Right. So here what we're saying is k starts at 2, right? And while k is less than the factor that we're going up to. So if in our example we said n is 37, so while k2 is less than or equal to 37. So is this true in the first time we run it?
Yes.
Good. So then we immediately go to the next one, right?
Yeah.
Good. And is this true?
Yes.
Now we have to look at it. So n is what? 37.
Oh, no, that's not true.
Yeah, so 37 modulo 2 is what?
Not 0.
Not 0, that's for sure. Okay, so this is checking what? Are you
Even.
divisible by this number with no modulo, right? So that's the definition of divisibility. Now we used this for even and odd, right? Because how we define even is, are you divisible by 2 or not, right? So this is just that one step over. And so in particular here, what we're looking at is, okay, the thing that's changing here, n is going to be the same, 37 or 36 or whatever you want. But each step, you're going to walk through all of the numbers that are less than the number that you're looking at, right? Okay, does this one make sense?
Yeah.
Okay, what does this do?
Adding to the factor list.
Good, good. So that adds to the factor list. So this only happens if this is true. Good. So this says this is a factor. We add it to the list. And then what does this do? That-
That's an integer divide, right?
That's an integer divide. What does that mean?
It means that whatever you get as after you divide n by, I think it's n by k, just chop off the decimals, whatever is left, so that way you're left with an integer.
Right. Does that make sense to people?
Yes.
Okay, and then we update k. K goes up by 1, and we go to the next one. And then you're going to have some factor list that comes out at the end, right? And so generally speaking, I'll recommend that if you do an example at home, that you go through and you try to understand what each of the lines are. This is a perfectly good way to learn how to code because you see it there. You're just trying to like understand what the language is that they're speaking. And so I'll always write comments, line by line comments. This does this, right? And that way I can understand the structure overall. Okay. Thank you, Zori, for doing it during the storm. Let's how many folks do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's break up into 4 breakout rooms. How do I do that again? Oh no. Let me stop the share and pause the recording.